So we left off talking about different ways to find the area between two curves. And this section gets into the difference between a vertical slicing method and a horizontal slicing method. So all the examples that we've done up to this point, we always drew our Riemann rectangles going vertically. We're going to talk about what does it look like if it goes horizontally. So it's not overly complicated when you go horizontal, but it's not something you would probably think of on your own. So let's talk about a vertical slicing method first. That means you integrate. So we're taking all of our regions. So I'm going to draw just some random curve here. All right, we're taking our regions and we're doing their height. So we're adding up the function values. So f of x. We're adding up how tall the function is multiplied by how wide that function is. So we're add up all these heights multiplied by how wide those rectangles are. That's the vertical slicing method. So this is the one that we already know how to do. So you should be able to do this one all on your own. So I'd encourage you to try to pause and get this sucker going on your own, and then maybe turn it on every once in a while to check where you are. All right, so the first thing I have to do, the region in the first quadrant, that's worth underlining. This is only the first quadrant that I care about. Bounded by y equals x, y equals 0, and y equals x minus 2. Well, let's start off with the toughest one, which is y equals the square root of x. Now, hopefully you remember this from your family of functions. All right, I'm going to count over 1, 2, 3, 4. I'm going to count up 2 because I already know how that family behaves. The square root function starts at 0. 0, 0. Then when I go over to 1, what's the square root of 1? 1. When I go over 2, what's the square root of 2? Crappy. 1.4, blah, blah, blah. Square root of 3, also crappy. Square root of 4, 2. So hopefully you got a curve that looks something like that. Then I want to graph y equals 0. That's easy. Well, why did they even write y equals 0 in there? I guess that's the whole idea of the first quadrant. They've kind of restricted us by the first quadrant. I guess I'll draw that in there too, just so we can see it. This is y equals 0. And now the real fun one, y equals x minus 2. Hopefully you remember that as a line. Hopefully. Then we can sketch that line now. So y equals x minus 2. That's going to start down at 2 as a rise of 1, 1, 1, 1. Oh, I know. That's kind of nice. We got a point of intersection there. This is y equals x minus 2. And I'm not going to bother labeling these as y1 or y2 or y3 because I don't get to use my calculator anyway. So I'm going to have to integrate, so there's not really any benefit. So let's now try to highlight the region. So to kind of just think about how you would write up an integral that would find that area. Think about what are the things you have to consider. So what I considered when I was going through is that it's not going to be just the green function subtract the yellow function because of this restriction that we are trapped in the first quadrant. So as I move from, if I look at this region, as I move from left to right, the upper function in this is green. Who's the lower function in this first part? Is pink. Then at this spot, it transitions to being the upper function green, lower function yellow. So we have to find out where this place is. Let's just double check. Is that going to be the spot x equals 2? Let's just double check, right? So we went over 1. Yep. So up 1, over 1, up 1, over 1. Or you could just take 2 and plug it in. 2 minus 2 is 0. That's where the orange line is going to intersect the pink line. So we're going to have to write up two separate integrals. Try it on your own. So area, I want to get in this habit of writing area equals all the time. I did it on those two, good. Area equals, all right, my first region is the integral from 0 until 2 of, now I got to do this by hand, so I might as well just write it out. My upper function is square root x minus my lower function is 0. I'm going to enjoy integrating that. How come I'm wrong? Dx plus, then my next region starts at 2. Ooh, where do these intersect? Now, we kind of did a nice job when we were going up and over, but so we should just double check. 4 minus 2 is 2. Square root of 4 is also 2. So we're going from 2 until 4 of, now the upper region is square root of x minus my lower region is x minus 2. How come this is wrong? Error alert. Error alert. Two things you can do here. You can either, it's right there, either use parentheses or distribute. You can pick, I don't care which one, but this would not be correct. I should either put parentheses around that or I should distribute the negative as I go. And so for me, it's easier to just distribute the negative as I go. There's other equations that are more complicated that I wouldn't do that with, and I'd take another step and try to clean it up algebraically before I integrate it. All right, well, let's integrate. You should be able to pause and do this on your own. So 1/2. All right, so the integral of x to the 1/2 would be x to the 3/2, 2/3. 2/3. Integral of 0 is 0. 0 to 2 plus, hey boy, this one's going to be a little bit more complicated. So that's the same as this. So this is going to be 2x to the 3/2 over 3 minus x squared over 2 plus 2x from 2 to 4. So we can put 2 in there. So this would be what? 2 times the square root of 8 over 3 minus 0, so I don't care about that, plus, okay, we're putting 4 in here. So let's see if we can do this part in our head. I'm going to square root the 4 first. That's 2. 2 cubed is 8. 8 times 2 is 16/3 minus 16/2 plus 8 minus, oh, we're in the same boat here, so this is going to be 2 root 8 over 3 minus 4 over 2 plus 4. All right, let's see if we can start to combine some stuff here. I'm going to just make this 8 because I see that plus 8 right afterwards. Minus 2 root 8 over 3. I like that. Minus 4, that's 2 plus 4. Okay, so life is good a little bit. Those guys are gone. So I have 16/3. Those two are gone. Plus 2. So that would become, whoa. I forgot to distribute the negative. That's going to make this a plus and this a minus. So this is going to be subtract 2. So if I times that, that becomes 6 over 3, so we get 10/3. Look at that. That silly mistake, man. I had my answer key that I already did these notes earlier, so I caught it. But, man, I don't think I would have caught it if I didn't have that stuff. So you got to really be diligent about those things. All right, so how does this problem change when I want to do a horizontal slicing method? So now instead of, I should have drawn my little, I forgot my representative. This is dx, and then the height of this is equal to the upper minus the lower. Now that changed over time, but that was still the idea, okay? So I would do that over here. This would be dx, and it's still upper minus lower. When I want to do this with a horizontal slicing method, I'm looking at it from left to right instead of up and down. So I'm going to redraw my curves. I'm not going to draw them as detailed this time because we know all the points of intersection from the last example. Now here's where the game changes. So this was at 4, this was at 2, and this is still my region. So at the end of this, we still should get 10/3. But look at how we're slicing it now. I'm not going to slice this vertically. I'm going to slice it horizontally, which means I'm going to make a cut this way. That's going to have a width of dy because that's now going in this little width here, I'm trying to draw some thickness to it, but that width is dy. This then becomes, instead of upper minus lower, it's right minus left, because I want to take the furthest right function and then I'm going to subtract the furthest left function. So this time I can do this all with one integral, because according to this region, who's the farthest to the right? Always the line is. Who's farthest to the left? Always the square root of x. So let's see if we can figure out now. I'm going to put these points back in here. This was the point. This is 0, 0. This is 2, 0. My bad. This is 0, negative 2. This is 2, 0. This is 4, comma 2. And then this is 0, 0. So those are all kind of the important points that we might need. So let's integrate this. So I want to find the area. The integral from. All right, now we're thinking about this in terms of y's. So we're going to take the low y until we get to the high y. So what's the lowest from this curve, this region? What's the lowest y value? The lowest y value is 0 until we reach what height? What's the largest y value? That's going to be 2. So our graph starts at the bottom, a height of 0, and it reaches a top height of 2. Now remember, this region up here, we actually went from 0 until 4. That's because the low end on x was 0 and the high end for x was 4. Now we had to break it up because the heights, the upper and lower functions changed over the course of the curve. In this case, that's not true. In this case, our low y is 0 up until our high y is 2, and then always, the line is always to the right of the square root graph. So if the line is x minus 2 minus the square root graph. Now, shoot. Sorry. If you want to integrate, my bad, look at what we're integrating according to is y. We're integrating according to y, which means our equations need to be rewritten in their y format. So in this case, usually you wouldn't, I'm forcing you to do it here. Normally you would just do like we did up above. I just want to introduce this idea to you because down the line, they're going to sometimes give us equations that have solved for x. Now these ones are pretty easy to solve. So let's solve this. I would get x equals y squared. And I would get x equals y plus 2. So now this graph, I'm going to go to my yellow graph. This is really the graph x equals y plus 2. And the green graph is x equals y squared. It's probably got to be restricted a little bit because that would include the lower part. But I think we're only going from 0 to 2, so we don't have to worry about really there's a second branch here. I don't know if you remember that from your parabola days, but there's got to be 2 branches. We don't have to worry about that lower branch because we're still only integrating from a low y of 0 to a high y of 2. So now when I integrate, area equals the integral low until high. So my lowest y is 0, my highest y is 2. And then my further right equation is y plus 2 minus my further left equation is y squared. Now, like I said, you wouldn't probably do this unless they made us do it horizontally. But if you're going to integrate according to y, your equations have to be written with y. So it has to be like x equals y stuff. Just like up here, we needed it to be y equals x. X was the stuff that was, or y was by itself. Down here, we need to get x by itself. So you should be able to integrate this on your own. Pause if you haven't yet. Over 2y minus y cubed over 3. Double check that. Yep. Remember, you can just derive these to see if they're right. So this would be 4 over 2, which is 2, plus 4 minus 8/3 minus 0. That's an easy one. So 6 minus 8/3, which would become 18/3. 18/3 minus 8/3 is 10/3. What a shocker. So it comes out to be the same. So like I said, look, this other way, this horizontal slicing method would be forced on you in this case. So I told you you had to integrate f of y dy. I should have written that earlier. That probably would have helped us to catch on that everything needed to be written in terms of y. So let's take a look at an example where they have already, this is what I'm talking about. This is a situation, because they told us that x equals already, this is a situation where you're going to want to integrate horizontally. Okay, so what would that look like? So this is a hint that I'm going to integrate f of y dy. F of y dy. Let's draw a picture. Now this is a calculator permitted problem. So I'm going to use my calc, but I still want to get a decent sketch going so that I can find the region. Okay, so my calculator only graphs in y equals mode. So I'm going to leave this in y equals for now until I get a picture. And then I'm going to convert it into x equals. So I'm going to move this over, and then I would square root. So I would get the square root. So y equals plus or minus the square root of x plus 2. So I want to do the square root of x plus 2. And then the negative square root of x plus 2. I should have done a zoom 6 first. Never mind. I'm going to see, zoom in. I'm going to try to just zoom into the middle. Let's see if it gives me, if it breaks it down better. I don't think it did. I think it made it worse. I'm going to do a zoom 6. Get me back to my standard window. And now I'm going to do a zoom in right at 0, 0. Oops. I'm going to do a zoom in. See if that gives me a better picture. Oh, that's a beauty. Okay, so now let's try to sketch that over here. Well, we can figure that out later. I'm thinking that that's -2, but we'll check it out later. So I have one curve going like this. Curve going like this. Now there's two ways for you to write that up. If you are going to integrate dx, I'll talk about that in a second. Let's get this other one going. Okay, so my region. Now you can integrate this according to x if you want to. Feel free. That's fine. You'd have to, it gets a little bit sneaky on which one of these if you're going to, how about this? Let's do it this way. If you're going to integrate according to x, this graph is y equals the negative square root of x plus 2. This is the graph of y equals positive square root of x plus 2. And then this is the graph of y equals x cubed. So if you wanted to go in the x direction, you'd have to look at these and try to figure out who's the upper and who's the lower. So like your first region would be here. That would be the upper would be this function minus the lower would be this. Then the next section would be from here to, oh, we could go from here all the way to there. And that would be this is the upper and then this is the lower. So if you wanted to go that way, that's fine. Or you could do it in the y direction. I want to do it in the y direction just to practice that again. So the other way to look at this is the same as x equals the cube root of y. Know what I mean? I can rewrite this for x. Oops. I could have done that. X to the y to the 1/3. Cube root, same thing. Or I can look at this whole pink curve. This whole pink curve is the same as x equals y squared minus 2. Now, x equals y squared minus 2, that's the whole curve. It's the plus and the minus case. It's when we solved it for y again that we had these two different parabolas, because when you go y equals, you can't violate the vertical line test. When it goes x equals, you can't violate the horizontal line test. So like I said, I want to do this with dy, because then I only have one integral that I have to integrate. Okay, so from a y perspective, who is further to the left? Who's further to the right always is x, the cube root of y, and then who's further to the left is x equals y squared minus 2. So I've got to find some points. I've got to find the low here. I got to find the location of this point, and I've got to find the location of this point. So we have the curve already graphed. So second calc, intersect. Remember, you hit guess, and then take a guess. Oh, wait. Shoot. I've got too many curves in there. Let me quit. Let me show you again what I mean. Now I hit second calc, intersect. Now look, it says y1 equals x cubed. So I want to find the intersection of x cubed and this curve. So when I hit enter, it jumps me up to this curve. Well, I can go over there and it'll find now the intersection of those two. So you got to be real careful. Who are they trying to find the intersection of? And so that found our point up there. So this is the point 1.214. Comma 1.793. And I know I'm going to need that in my integration, so I'm going to store that as A and then B. Now I'm hoping we're going to have a C and a D here. Let's see what this comes out to be. Let's find this point of intersection. Now the way we graph this on our calculator, we're going to use this is the x cubed graph, and then this is the negative one of those functions. So I'm going to go second calc, intersect again. My first curve is the x cubed. That's good. I'm going to hit enter. Now, this is going to take me to that curve that we already intersected with. But if I hit the up or down button, it'll keep jumping between the curves. So I'm going to jump until I'm on the curve that I want. I'm going to move a little closer, even though this is the only place they intersect, so I don't need to really do it, but I'm going to do it anyway. Oh, bless. -1, -1. So I don't have to store that now. Oh, shoot. I forgot to store this as A and B when we had it. So now I got to go back and store this. I was so excited to see what these were. Let's see if we can do this one quick. Second calc, intersect. I want to do the cubic curve, enter, and I want to do that curve. Good, enter. It'll take me there, and then from here, if I want to store the x and the y, I got to quit out. X stored as alpha A. Now we've got that 1.214. Alpha 1, which is y, and I want to store that as alpha b. So now we've got those things stored. All right, so I'm integrating according to the y. So I'm integrating in the horizontal direction. So my area would be, dang it, I did A instead of area. equals the integral from, okay, what's my low y value? Now, we got to be careful. This is not a low y value. Wait, yes, it is. Yes, it is. We're okay. That stumped me for a minute. Yeah, that's okay. So we want to go from -1 until what's our high y value? Our high y value is b of, and let's see now, they did, this would be, who's the further left? Sorry, who's the further right? That'd be the cube root of y minus, that would be this, which is y squared minus 2, but I'm going to change that to a plus 2 because I want to distribute the negative dy. All right, so let's see now. So I'm going to integrate math 9 from -1 until b. Okay, now these are y's here. You can put them in as y's if you want, or you could put them in as x's. It'll give you the same result either way. I'm going to put them in there as x's. So I'm going to go on a math cube root of x minus x squared plus 2 dx. See if we get 4.215. 4.214. Sorry, 5 was how I used to when I used to round. 4.215. All right. So just to prove to you that I could have changed those all to y's. Alpha y, alpha y, alpha y. Now, unfortunately, it's going to take just as long to think. No, I don't want a 215. I want a 214. I don't round like that anymore. 4.214. What did we get? 4.214. Now, look, you could change this y to any letter that you want as long as you change all of those letters. It doesn't matter. Even though the b is still there, that's okay. That's okay. Okay, just to show you that you could have done this from the x perspective, I'm going to encourage you to try to figure this out from the x direction. Okay, from the x direction, I've got to go furthest left. The furthest left is this point over here. Well, where is that point? If I go to my grapher again, I think it's at -2. I was on the wrong curve. You see how up here it tells you which curve you want to look at? So -2, yeah, for sure, right? Because what's -2 plus 2? That's 0. So this is -2. X equals -2. So I want to go the integral from -2 until now. Look, you got to be careful here because we're looking at who's upper and who's lower. Because right now the upper is the square root of x plus 2, and then the lower is the negative square root of x plus 2. So that would look like the square root of x plus 2 minus the negative square root of x plus 2 dx. But then at 1, this now switches to no longer looking at those two curves. I probably should have done this in a different color, but I didn't, so we're going to have to live with that. So until -1 plus the integral from -1 until, now I want to go until a this time. I want to stop at this x value, not this y value, because I'm going according to dx of, now who's the upper function? Square root of x plus 2 minus, who's my lower function? X cubed dx. All right, here's the moment of truth. Now, did I store these? Yeah, so I'm just going to use my y1s and my y2s to save myself some typing here. So quit out of here, clear, clear, clear. Math 9, I want to go from -2 until -1 of, okay, this is what I called y1 minus y2. No, I didn't. That's y1, that's y2. So this was y1, this was y2, this is y3. So let me go back here. I want to do y2 minus y3 according to x plus math 9 from -1 until a of y2 minus y1 according to x, 4.214, 4.214, 4.214. Either way works. Okay, let's see if you can try this. The whole this next part you should be able to do on your own. See if you can do it. All right, so sketch the graph of the two functions and identify the region bounded. So I could sketch these by hand, I think, but I get calculator permitted, so I'm gonna double check. This is gonna be a shift up of the exponential function, and this is gonna be a shift up of a reflected parabola. But I wanna get a good window. I wanna have my calculator help me find a good picture here. So e to the x plus 1, 2 minus x squared. I'm going to do a zoom 6 first. Oh, there's my parabola. Boy, if I were to predict where my region of, because that's not good, that's not good. Those are all areas that are infinite, so it's got to be right in there. So I'm going to do a box this time, and I'm going to take my box and zoom it in that region that I think it's covering right there. Let's see how that looks. Yeah, boy, it's still a real tiny little sliver of a region, isn't it? So I've got one curve going like this. And then I'm going to exaggerate it so that I have plenty of room. And I have another curve. Oh, man, I wish I would have drawn that a lot better, but I didn't. So going like this. That should have been way back there. That's a pretty terrible drawing. But as long as I label everything, we good. So this is going to be the graph of y equals 2 minus x squared. I'm going to call that y1. This is the graph of y2, which equals e to the x plus 1. Then this is the region that I'm trying to figure out. I'm going to go for these intersection points right now, since I've got my calculator right here. So second calc, intersect, guess, guess, and guess. Yeah, that was that. Oh, remember this notation. That really means 0. E to the -14. In chemistry, that's a real number. In calc and math, that's your calculator making a mistake. So that's the point 0.02. This is the point. Second calc intersect. I'm going to hit guess and guess again, but this time when I get to guess, I'm going to move my cursor closer to that other intersection, and we get -1 point. Nope. How about let's go down here. Nope. Let's go over here. -0.714, comma 1.48. Good night. This sucks. How about over here? -0.714, comma 1.489. And right away, I'm going to store this as A and B. I don't know if I'm going to use them later on, but I don't want to have to retype all this in there again. So I'm going to do a quick X stored as A and a quick Y stored as B. Oops. Okay, now they're stored in there as A and B. Boy, I wish I would have drawn that a lot nicer, but we're stuck with that. Find the coordinates of the points of intersection. Hey, life is good there, man. That didn't take long. Oh, show your work. That takes a little bit of effort. Not much, but just a little bit. Show your work. So how would you figure out where these two curves, if I said do it algebraically, how would you figure out where these two curves intersect each other? What could you do to their equations? Hopefully you said set them equal to each other. Now, if this was not a calculator problem, you'd have to keep going from here. But since this is a calculator problem, we can find our points of intersection as 0, 2, and negative 0.714, comma 1.489, which we already called A and B. Now, I think you could have just written AB here because we defined it up there, but because you did I did such a crummy job of writing that, I would recommend writing that again so it's very clear to your grader how that works. Using vertical slices. So now I'm going to redraw my region. I'm going to draw it better this time. Dang it. I thought I was going to draw it better. Using vertical slices, so that means they're going this way. So our width is down here, so this is a dx. So that means the height is going to be upper minus lower. Do we have a change here? Do we have a change in who's upper and who's lower? No, we don't. So we can go ahead and go right for our area equation. Area is going to be equal to the integral from, okay, who's the farthest left would be A. Who's the farthest right would be 0. Who's the upper function? Upper function would have been the parabola, so that's 2 minus x squared minus ex minus 1. Where's that minus coming in? Hopefully you said from the from distributing the negative. So you could type this in. I'm going to type it in because I already stored those as y1 and y2. I'm going to do it as that. Now, who's who? So I'm going to rewrite this. Oh, I did write it. No, I didn't. No, I didn't. I should change that. I'm going to call this y1. I'm going to call this y2. So for us, that would be the integral. Quit out of here. Math 9. I want to go from A until 0 of, which one did we call this? y2 minus y1 dx. Dang it. And we get 0.082. That seems reasonable to me. Remember how small that little sliver was on the picture. Now we're going to do the same thing, but we're going to do it with horizontal slices. So this is going to be the third time I get to draw this curve. Let's see if it looks decent the third time through. There we go. This is my region. Okay, this time we're doing horizontal slices. So this is going to be one of my rectangles. That's going to have a width of dy, or a height of dy. And then maybe you could say the width is going to be right minus left. So the further right, the further left. All right, we have enough info, plus we get to use our calculator anyway. So what's lower now? I want to figure out what's the lowest y value compared to the highest y value. So my lowest y value is going to be whatever this is. So I go back up here, that lowest y value would be B. The highest y value would be the y value here, which we figured out was 2. Then we want to go from the left. Oh, man. Why am I annoyed again? Because this equation is solved for y, not x. So we have to rearrange this so it says x equals. So let me get some different colors. I'm going to do it up here instead of down here. So I'm going to take this guy. I'm going to subtract 1. What gets x by itself would be natural log. We don't need absolute values if that's what you were thinking. If you're thinking absolute value, that's a good thing that you thought that. But you should remember that we don't actually need them because we didn't integrate. All we're doing is killing e to the. So this one's a little bit easier. I'm going to swap the x's and the y's. I got to be careful. This is plus or minus. Because of where this region is, though, let's think about this a little bit harder. What half of the parabola are we going to need? The positive half or the negative half? So if I go back to my picture down here, this is y equals the negative square root of 2 let me try again. X equals the square root of 2 minus y. Dang it. Forgot the negative sign. X equals negative square root of 2 minus y. And then this is x equals positive square root of 2 minus y. So this portion is not even involved with our region, so we don't have to worry about that. So over the course of this region, who's further to the right side is the exponential. So that's this graph, x equals natural log of y minus 1. Minus a negative, I'm going to put it in parentheses just so we don't get confused on where it's coming from. And we're integrating according to y. We can use our calculator here. Pause at any point and think through this. I'm kind of going quick. Alpha, nope, math 9. From b until 2 of natural log. If you want to use y here, you can use y. If you want to use x, you can use x. It doesn't really matter which. I'm going to use x because they have a button. I don't have to, it saves me one keystroke. Minus negative square root of 2 minus x, not 9, parenthesis, and then another x. We should get that point. Oh, I used a subtract instead of a negative. We should get 0.082 again, unless I messed it up. Nope, we got it. All right, this last example, this takes a lot of work to kind of explain all at once. Maybe I'll come back and make this video. I'll make a video for this in the future. But this is, I think I got to do a lot more legwork than just have you try this problem. So I'll stop here.